Hello class, welcome to Unit 3.3a, Functions, Domain, and Range. So taking a look at the definition of a function, this is a special relationship between values where each input, so your x value, has exactly one output, one y value. So what that means is we are looking for essentially more than one of the same x. So if we kind of look through what is listed here as a function, if you look at all of your x values, -3, -2, -1, 2, 3, none of them repeat. So that is telling us that all of our y values, there's no one x value that would have two y values. Where if we look over here at our example of not a function, as soon as you see -3, -3, two of the same values, this is telling us that that x value has an output of 2 and 4. That is not what you want to see. We could care less that there's like two y values. When you're trying to find a function, we are strictly looking for two x values that have multiple different y outputs. So let's take a look at how we can find them through a few other examples. All right, so in this example, let's determine whether the given relation is a function. So again, when we're looking at ordered pairs, essentially what you're looking for is two x's. So if we can go through all of these x values in number 1, 5, 3, 2, 0, -1, and as long as we don't see any repeats, then yes, this one is a function. If we look at 2, what you're looking for is -2, 0, 2, 3, 2. Oh, I heard 2 twice. So we're looking here. We have two x values that are giving us basically two different outputs. So 1, 2, giving us two different outputs. This is not a function. Okay, let's take a look at trying the other two on your own. So please pause here before we check your work. Determine, are these a function, yes or no? Okay, due to the fact that we have a -3, -3, no, this one is not a function. And if we look at 4 and see no repeats, 1, 2, 3, 4, 5, yes, the second one is a function. Okay, let's take a look at finding them in tables. Once again, we are want to remember that we are looking for two of the same x values. So if we look at example 5, up here is a 3, and then we got -1, 0, 2. So we have two 3s, again with different outputs. So no, this is not a function. If we look down through 6 and look at all of our x values, -4, -2, 1, 2, 5. Okay, so that's telling us there's only one of every x. So yes, this one is a function. So again, just coming back to finding multiple x's. Okay, pause here and take a minute to kind of look through each of these problems before you check your work. Okay, the only one we found here that is not a function would be 8, because we find 4 and 4 with different outputs. Okay, let's take a look at some more. Okay, looking at these examples for mapping, again, we're looking for multiple x's. So if you think about how we ended up drawing these were the ones we're looking for in your x values. Are there any of these that end up going to two different y values? So in this case, there's a singular line coming out of them. So that first one is a function. If we are looking at 12, we are looking at -1. And if you remember, when we drew these, this one is drawing to two different y values. So that is exactly what we're looking for. We are looking for an x that has more than one. So in this case, it is coming to -1 and 7. So this one would be no. And if we look at 13, drawing each one of these is only going to one number. So yes, that one is a function. Okay, guys, so we're going to take a look at the vertical line test. So if a vertical line intersects a graph more than once, then it is not a function. So what we're going to be looking for, again, is for each x value, and we're just going to be kind of drawing these little arbitrary lines, making sure that every time you draw a vertical line through your graph, it intersects 1 point, 1 point, 1 point, 1 point, 1 point, and 1 point. So what that's going to tell us is that is a function. Because remember, each x can only have one output. When you look at something like this, where you are now looking through quite a few of them, where at that x value here, it's going to have 2 points. And that's going to repeat pretty much through this whole circle. So that would qualify this as not a function. We should only be seeing one y for every x. So let's take a look at a few more. Okay, looking through these couple examples here, remember, you are just looking vertical line test. So you're kind of going through, passes. That point passes. That point passes. But as soon as we get through 1 point or one vertical line that goes through 2 of them, no, that is not a function. What we want to see is like 15, where vertical line passes 1 point, 1 point, 1 point, 1 point. So yes, this one is a function. And as you kind of work through them here, obviously you're kind of scanning the whole graph. And it's not necessary to draw these lines the whole way through. We're just looking for essentially one that does not pass. All of that one does pass, so that is a function. And then when you look over here at 17, well, you can pick just about anywhere on this graph. And those vertical lines look like they're going through 2 points on your graph. So this one we are looking to call no. Okay, so that is your vertical line test. A lot of these you'll be able to look through. So just try, all you're looking for is 1 point as you practice through them. If you can draw one vertical line that goes through 2 points, that automatically makes the whole thing not a function. So take your time, pause here before you check your work. Okay, so there's what we should be coming up with. No through your circle, yes through the V, no through this vertical line, because basically everywhere on there is going through a point. And then yes for that last one, has some ups and downs, but no repeats. Okay, at this point, make sure all of your work from your ALEKS and worksheets from the past 2 lessons are all caught up as you finish up today. All right, have a nice day.